Okay, we're going to be doing the phet, forces in motion. We're going to be doing part 1 of motion. So we've already done the net force, so click on the motion one. Now, in the beginning of your book, it says to click on the motion tab at the bottom of the screen, click all the buttons in the box in the upper corner. So we're going to click all the buttons. It says put each item listed in the table on the cart one at a time. And then click the double arrow on the right to see. And when you click, it should say 50 newtons. All right, so right there, if you click right here, the double arrow, it says 50 newtons. So that's the amount of force that's being applied in that direction. All right, so you're going to record how long it takes to get, or the speed that the box is at when it reaches the second tick mark right there. And you're going to do it for each object. So the very first one, we're going to click reset. The very first one that we're doing is the girl. So we're going to click reset. We're going to take the box off. We're going to click all the boxes, put the girl on the skateboard, and then we're going to click 50 newtons and we're going to push play. And we're going to see what the speed is at this tick mark. So it is 7.7. So when we talk about speed, we need to know that speed equals velocity. Now, velocity is speed, but with direction. Okay, so we're going to have to say when it's velocity, it's speed to the left or speed to the right. Speed is just meters per second. But your units are meters per second for velocity. So we're going to fill in our table for the velocity of all of these objects. And you also need to record the mass. So the girl's mass, we see right here, is 40 kilograms. So we're going to write that right here. And her velocity was a 7.7 meters per second. And we're going to do that for each of these objects. So you have to click this button that's circular and it's reset. So the next one is the trash can. So we put the trash can, we click all the boxes, we do 50 newtons, and we stop it when it gets to the second tick mark. So that's 8.0 meters per second. And the trash can's mass was 100 kilograms. So I'm going to pause the video and I want you to finish this, and we're going to come back and I want you to check your amount. Okay, so I've filled in the data table with all of my velocities and all of my mass. So now we're going to calculate the acceleration for everything except for this mystery box, because we don't know the mass of the mystery box, so we can't find the acceleration of it. And we're going to use the formula F equals ma. So we're going to find the acceleration for each one. So I'm going to write girl. And remember, our formula is F equals ma. Now, we are looking for acceleration. So my magic triangle tells me that I've got force on top and then m and a on the bottom. I'm going to cover a up to get my new formula. So my formula to solve for a is a equals F over m. Now, this F right here stands for force. The A is acceleration. And the M is mass. Now, acceleration is something that we also need to know. So I need you to write down acceleration equals speed over time. So that basically means how fast something goes in a certain amount of time. So if you said, I was traveling to the beach and we went 60 miles per hour, and it took us 2 hours to get there. Well, then we could calculate your acceleration based off that because you gave me speed and how long it took you to get there. So going back to our girl, we're finding accelerations. We have to fill in force. Well, our force is 50 newtons. So we have 50 newtons over M, which is mass, and our girl's mass is 40 kilograms. So 50 divided by 40, and we get 1.25, and our units are meters over seconds squared. So the units for acceleration are meters over seconds squared. So seconds times seconds. So I'm going to come back to my table and I'm going to write my acceleration as 1.25. Now I'm going to do the trash can. I'm going to use the same formula because I'm solving for acceleration. A equals F over M. My force is 50 newtons over my mass, which was 100 kilograms. 50 divided by 100, we get 0.5 meters per second squared. So I'm going to write that on my acceleration, 0.5 meters per second squared. So I want you to go through and solve for all of these, okay? Now, the only one you won't be able to solve for, remember, is your mystery box because you don't know the math and you have to have the math solve for it. So pause the video right here and fill in your work for all of these. And this is what I will check, okay? Now, we're going to solve for the mystery box now. And number 6 tells you to calculate the mass of the mystery box using the formula for acceleration. A equals VF minus VI over T. The time it takes the box to reach the second large tick mark was 7.45 seconds. Your initial velocity is starting from stop. All right, so what that means is your formula is A equals VF minus VI over T. Well, that VF stands for final velocity. The VI is initial. Velocity. And the T is time, and your A is acceleration. So you would use this formula when you don't have mass, but you do have the time it took, and you have the final velocity and the initial velocity. The word final means end or stop. The word initial means the start or the beginning. So on your mystery box, when you use this formula, A equals VF minus VI over T, our final velocity was where it stopped, which was 7.8 meters per second. So we're going to say our final velocity equals 7.8 meters per second. So our initial velocity, so it said we started from stop. So that means our initial would be 0 meters per second. Our time was 7.45 seconds. And we don't know acceleration. So now we can just fill in our formula. So A equals VF, which is 7.8 meters per second, minus VI, which is 0 meters per second, all over T, which was 7.45 seconds. 7.8 minus 0 is 7.8 meters per second over 7.45 seconds. 7.8 divided by the 7.45, and we get 1.05. Now let's look at our units. We've got meters on top, seconds on top, Or seconds on bottom, seconds on bottom. Well, these can't cancel, so they have to combine because they're both on the bottom. So we've got meters over second squared. So that's our acceleration for our mystery box. So it was the 1.05 meters per second. Well, now we can solve for our mass because we know our acceleration. So we've got F equals ma. We know that our force was 50 newtons. We know our acceleration was 1.05 meters over second squared. So we need mass. Well, looking at our magic triangle, we've got force, mass, and acceleration. We cover mass up, so it gives us mass equals force over acceleration. Our force is 50 newtons over our acceleration was 1.05 meters per second squared. When we do the math for that, we will say 50 divided by 1.05, and we get 47.62 kilograms. So that was our mass for our mystery box. Now we're going to discuss number 7. So it says, what happened to the acceleration when you doubled the mass, when you compare the girl to the man? All right. Well, our man, when we solve for acceleration, we got 0.625. So our mass, or our acceleration, has doubled. So our mass halved and our acceleration doubled. So the man has double the mass of the girl and half the acceleration of the girl. So it says, what happened to the acceleration when you double the mass? Compare one box to two boxes. Well, if we doubled the mass of the man to the girl, then that means it would half the acceleration. So double mass equals half acceleration. All right, number 9 says, what did you learn from this activity? So you could have learned multiple things that I want you to write down. But to wrap all of this up, basically what you need to understand is, as you increase mass, you decrease acceleration. If the force is constant, meaning your force does not change. So if force is always 50, then you increase mass, you decrease acceleration. Because think about it, it's much harder to push a heavy box than it is to push a light box. If you push a heavy box, you're going to go real slow. But if you push a light box, you can push it really fast. So if your force is always the same. Now, we're going to talk later about when your force changes, what will happen to these two things. But I want you to write on number 9 what you have learned from this video.